So, welcome everyone to another edition of the Aurora Academy. So, today what we'll be looking at what is cryptocurrency. So, in simple say, cryptocurrency can basically be defined as a digital form of exchange. It is built with the help of the blockchain. And one thing we need to understand about cryptocurrency is there is no central authority. Nobody is controlling the value and nobody is controlling how it is being distributed. As far as you have your wallet and you have your money, you can interact with cryptocurrency and you can get cryptocurrency in a wallet. No one have any central authority. All you just have to do, you have your money and you have your wallet to get your own cryptocurrency. So that is basically what cryptocurrencies. And with the help of this cryptocurrency, it has and let's assume that and there are some issues that this cryptocurrency can solve. Look at this naira crashing and all that. Adibin cryptocurrency is not owned by one central authority, and let's assume we have all let's assuming that all industry, all manufacturers are accepting this coin. We won't be that affected by this inflation and all that. So now let's now look at let's now move further into what we have for today. We are looking at cryptography. So cryptography is a way in which if cryptography enables us ensure that information transferred between two entities are secured. It is an approach in which we ensure that information being transferred between two entity are secured. And the way that information is being ensured that the way we ensure that the information is being secured is we convert the information to another form. So we can just convert the information to a simply a length to a characters comprises of numbers, string and all that. So now after converting these numbers this information, the real information, to a series of characters and numbers, then we can then send that characters and number to the person we are intending to send that information to. And the process of converting this information to a series of characters and number is known as encryption. And the process of converting the information, the real information to its original form is known as what? Is known as decryption. Now we now have different cryptographic approach. We have different type of cryptography. Now let's look at the type of cryptography we have. We have the symmetric cryptography, we have the asymmetric cryptography, and we have the cryptographic hash. And this cryptography is one of the technology that is being used on the blockchain, and that is why we are interested in understanding what cryptographic is, because it also enables us to understand the fundamental aspect of the blockchain. Now let's look at the symmetric cryptography. Now let's say now you are a military personnel and you have a colleague far away and you want to send a very classified information to it. So let's assuming you use platforms like Gmail. If you are just sending a raw information through Gmail, you definitely know that Gmail is not a decentralized platform. It is a centralized platform. That is, Gmail themselves, they can just go to their database and look at the information you are sending to your colleague. So now, but with this help of this symmetric cryptography, we encrypt this information with the help of a key, and we decrypt this information with the help of that same key in which we're using encrypting this information. And I said encryption is basically converting data into another form, or less in simple term, masking the data. You are basically masking the data. Now this symmetric cryptography, so now with the help of this symmetric cryptography, you use one single key to encrypt this information. Then the person you want to read the message, you just give the person, okay, take this key. This is the key in which we will use in converting this information to the original form. So that is in simple time, that is what symmetric cryptographic is. There's just one key that handle encryption and there's another key that handle decryption. Now let's look further into what we call asymmetric cryptography. Now, what is asymmetric cryptography? Asymmetric cryptography is when we have two different keys that handles encryption and that handles decryption. So now, in this asymmetric cryptography, the first key, one key is regarded to as private key, and the other one is regarded to as what? As public key. We are actually more interested in this asymmetric cryptography because that is it is used in the Web3 space. Let's now look at our wallet. Now, let me open my wallet. Let me share my screen. I'll be sharing my screen so that you will see. Trying to share my screen now. Okay. Can we all see my screen? Can we all see my? Okay. So now, this asymmetric cryptography. Now, if I open my wallet, we have in if you let me open my wallet. Let me show you what I mean. Now, in a wallet, we have what is called a private key, and and we also have what is called an address. So now we said symmetric cryptography. Asymmetric cryptography uses two different keys. We have the public and we have the private key. So why do we need to? Why did this asymmetric cryptography come in place? If you look at the symmetric cryptography now, there's a lapses there. Imagine I have two. Imagine let's look at that same scenario. I'm a military personnel. I want to send a two different highly classified information to two of my colleagues, and the two of my colleagues in which I'm sending the information to, I don't want them to have access to the information I'm sending to each other. So now, so if I'm now using asymmetric cryptography, then there's a possibility that the other person can still use the same key to open the information I sent to the other person, and the other person can also use the same key to open the information I sent to the other one. So that is the issue that comes with symmetric cryptography, because there's just one key that handle encryption, and there's just one key that handles decryption. So now, if we look at, I'm just waiting for my wallet to pop up. In a wallet, we have what is called a private key, and we have what is called a public key. So now, a private key is a private key enables the blockchain to determine that, okay, it is the person that owns this wallet that is performing a particular transaction. And that is why, let's say, when you want to send the money to your friends and family, MetaMask will pop up for you to sign that transaction. It is with the help MetaMask will pop up for you to sign that transaction. So now, as you are signing that transaction, e just as you are signing that transaction, your private key will be provided to the blockchain. So it is with this that the blockchain can determine that, okay, it's Mr. A that owns it is the original owner of this wallet that owns this transaction. So now, for some blockchain, and where public key comes to, and where public key are being used is, let's in some public some blockchain make use of some blockchain obtain it is part of the public key that they will obtain some of the wallet addresses. So different blockchain have different way in which they get their address. It's not as if they're just one standard way, but it's just good for you to understand that, okay, some blockchain actually get the address from the address is gotten from part of the public key. And so now, coming, let me unlock my MetaMask. So, one important thing is, that's why we are always asked to ensure that we keep our private key securely, because anyone that knows your private key, they can automatically log into your wallet and perform transaction, because the blockchain will see them as, okay, they are the original owner of a particular wallet. Now let's look at, let me show you. So now, account details. If I view my account details, export private key. So now I'm basically showing us this private key because this account I'm using is basically is not a useful account to me. So it's just like a account I use for demonstration. So this is my private key. So now after you create a account on a blockchain, you are given a public and a private key. So and some of the addresses of your wallet are basically part of that are basically is a part of the public key. Now let me now explain what the asymmetric cryptography is. The asymmetric cryptography in simple term is we have one key for encryption and we have another key for decryption. Let's say I want to send a message to my to let's you're also a mini personnel, want to send a message to your other colleague. So for them to just open the information, it is the public key that you gave to them. With just that public key, they can open that information. They don't really need your private key. So now so so with the other person too also, let's say you are sending the information to other people, you just give them your public key. With the public key, they can read the information. I don't know if we understand. Do we understand this definition of asymmetric cryptography? And do we understand?
Yes, we do.
Okay, that's good to hear. Let's now look at the cryptographic hash. So in short term, cryptographic hash works a little bit different from the normal symmetric and the asymmetric cryptography. So this cryptographic hash also is used on a blockchain because it enables us to ensure that the information on the blockchain are secured. And the way cryptographic hash work is that it ensures that an information is it ensure the authenticity of an information. Let's say now you have a contract, you are a two party, we have a two party involved, and you guys have to sign a contract that so 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 and so thing based on a particular agreement. Then after you guys have signed that agreement, what you basically do is you obtain the cryptographic hash of that particular agreement. And what is cryptographic hash? You can see cryptographic hash like a function that converts any data that is input inside of it into a fixed length of random string. That is, if you input A into it, it's going to give us a fixed length of random string. So now, after you guys agree on that particular contract, then you input the data into the cryptographic hash. It converts the data into a fixed length of random string. Let's now say the person now decide to go further and change the content of the agreement. The definitely the cryptographic hash will definitely change because the content of that agreement has been changed. Let me do a brief demonstration of this cryptographic hash for you guys and how it helps to protect the blockchain. So now so now let's say we input Ade is a fine boy. Let's say we put Ade is a fine boy. Can you all see my screen? So now
Yes.
let's say we input Ade is a fine boy as the content of our contract. Then an hash has already been generated to ensure that to an hash has been generated for a corresponding hash has been generated for this data. So let's now say watch the hash section of this particular bus. Let's now say I now change the content to Ade is IO. Then you realize that the content of this hash has been changed. So in basic term, hash enables us to ensure the authenticity of a particular information. So now imagine that after they've signed the agreement, the content of the contract has now been changed. Then they now ask you where is the hash? Then the other person that they signed the agreement together will just present the hash. Okay, this is the hash that was generated. Then the other third party that change that information, we the other party that, so when they now compare the hash to the when they now compare the hash to the newly generated hash, they will now realize that the hash has been changed. It is now corresponding to the hash in which they sign on, that okay, in which they sign on. So that is one importance of cryptographic hash. So now the way cryptographic hash ensures to keep the way cryptographic hash ensure that we keep the blockchain secured is that, now, in a blockchain is made up of blocks that are linked together. So now, if you see these boxes that is having this pale green color, we can classify this information as a block on the blockchain. Now, the way so now for the blockchain to ensure that the data, and you know that the way the blockchain works is that there's no central authority. We don't have a central authority in which we store our information on. Everything is decentralized. That is, multiple people come together to form the blockchain network. That is, it is not just one person that can. The blockchain is not just involving only one person. It involves multiple people to come together to form the blockchain network. And how does these people come together to form the blockchain network? It is the help of a computer. And each of the computer that exists in this blockchain network, they are regarded as node. Now, to now agree, now if multiple people are coming together to form the blockchain network, then definitely the blockchain is going to have a state. So now it's going to have a state to show that okay, these are the and it's going to have a state to show that okay, these are the information I currently have. So how do we ensure that this information how do we now ensure that this information that are stored in this block are secured? It is with the help of this cryptographic hash. So now this is the first block. Let's say now we are currently on one of the node that is forming the blockchain network. Let's say this is a block, and let's basically see a block is where we store the blockchain data, where we store the blockchain information. Now let's say at a particular time I'm transferring 200. Let's say I just store am on this data. So now after storing am on this data, then this current block is then distributed across all the other node, across among all the other people that is coming together to form the blockchain network. Let's now say part of the people that comes together to form this blockchain network, then they now decided to like cheat, to game the system, because it is because for us to determine the state of the blockchain, all the computer of these people that is coming together to form blockchain network, what we have on their computer must sync. That is, everything must be the same. So now if a person now decide to now okay, he want to change his own copy of the state of the blockchain. So now if a person now decide to change the state, so now if you realize now now if you check the hash section here, the previous hash is 000, and our the hash of the data here is 0000. Now if I input this, then this will be my new hash. So now this hash will be sent to other people that is forming the blockchain network. So after, let's now say a person that is part of the people that are now forming the blockchain network now decide to game the system. I will now change my data to something else. Let's say I change it to check the hash session. You realize that we are starting with D4. Then if I now decide to change my own content, what happens? You realize that the cryptographic hash have been changed. So this is how cryptographic hash ensures that so this is how cryptographic hash ensures that the information that are stored on the blockchain are being saved. Because if immediately the information is being stored, this hash will be distributed to other people, to other network, or we say will be distributed among other people that is forming the blockchain network. So now once the blockchain because the blockchain have its way of dictating if the information stored in a particular block have been changed, then once the information now creates an alarm that okay, the information has been changed, then all the other nodes or all the other people coming together to form the blockchain, they will now tender their hash. Which of the hash is different? Then they will now realize that it is the person that it is this particular person that want to change this blockchain the content of the blockchain, because its hash is different from the rest of the people forming the blockchain network. Then such a person will now be kicked out of the network. He will no longer be allowed to participate in the blockchain network. So now this is basically how the blockchain employ the use of cryptographic hash. And so I've made you guys see how the blockchain employ the use of cryptographic hash. So same thing too applies to asymmetric cryptography. Asymmetric cryptography is just that the asymmetric cryptography, the way it's being used on the blockchain is to verify that it is the original owner of a particular wallet that is creating a transaction. So that is what asymmetric cryptographic is, and that is what the cryptographic hash. That is how the blockchain employ it in ensuring that the information that are stored on the blockchain are secured. So, do we have any question concerning the cryptographic hash? Are there any question? Do we have any question regarding that? Hello, I'm sure I've release a lot of information. At least there should be a part of the information that might be confusing also. So if you have any information before I proceed, any question, I mean,
Yes, sir, you can continue.
no question, are you sure? Can I ask you a question? Hello, can I ask you a question? Th- Can
Yes,
any
you can go ahead.
can anyone explain cryptographic hash?
Yeah,
So what do you
from
understand?
what you have said, what I understand, you say it ensures the authenticity of the information,
Yeah,
right?
yeah,
You can convert it. It enables us to ensure the authenticity of an information.
yeah,
And you know that a blockchain is made up of blocks that are linked together.
yeah.
So with cryptographic hash, it ensures that a blockchain information are being saved.
Yeah, exactly. I tried. So, can anyone explain asymmetric hash? As said, any other person? Usman, um, Ajina, Josephine, anyone? Give us the meaning of asymmetric cryptography. Let me know that, so that I will, be- so that let me know if everyone is following, or maybe I should just come again. Wow, no one is talking. Usman, Josephine, please, let's talk. Wow. Wow. Okay. If no one is talking, Omajari, thank you for that. Yeah, actually, we're following, and to everyone that is silent, I don't know, why we are silent. At least, okay. So now let me move on. I've looked at cryptographic hash, and so now let's look at peer to peer. So peer-to-peer peer-to-peer electronic cash. And one thing we need to understand that the cryptocurrency itself is a peer-to-peer electronic cash. So before we now look at peer-to-peer electronic cash itself, what is peer-to-peer? Peer-to-peer basically refers it can it just we can regard peer-to-peer as activity that involve two party that does not require a central party or a central authority. Now let's look at our normal way of currency, our normal currency. If you look at this our normal currency, for you to we need the help of the a central authority. And the central authority that control the activity involving this is the CBN. For naira is the central bank of Nigeria. If they say this person account should be blocked, then his or her account will be blocked because of their influence, because of their the central authority. But when we come to the cryptographic hash, we said cryptography, we don't need any person, we don't need any central authority. If you want to send money to a third party, all you just need to do is tell the person, send me your wallet address, then you are going to send, then you send the money to the person. So that is just what peer-to-peer electronic cash is. Peer-to-peer electronic cash means a medium of exchange that does not require any central authority to determine to determine the activities that is going on around it. So you don't have a central authority. That is basically what peer-to-peer electronic cash means. Then we go further to look at Bitcoin. So what is we look at Bitcoin and altcoin. So Bitcoin is a form of cryptocurrency, and one thing we need to know that each blockchain has its own native token. For blockchain like Ethereum, the native token on the Ethereum blockchain is Ether. And for blockchain like Bitcoin, we said all these cryptocurrency are powered with the help of the blockchain. So now for Bitcoin now, the native token of Bitcoin is called Bitcoin itself. And for Ethereum, the native token on Ethereum is called Ether. That is why if you look at exchanges, what you see on it on them is Ether. You won't see Ethereum token. It is Ether you see on them. So that's why those one are called Ether, because those are the native token. So now we now look at Bitcoin and altcoin. So what do we mean by altcoin? Altcoin are cryptocurrency aside from Bitcoin. Any other cryptocurrency that is not Bitcoin, they are what we regard to as altcoin. And we have different type of altcoin. We have the likes of Ether. We have the likes of USDT. We have a lot of other cryptocurrency. So let me just talk about okay, so we have the like of Bitcoin and USDT. And one thing we need to know about USDT is USDT, they are stable, tokens. That is, their value don't change. So they are basically created by pegging them to a US dollar. That is, for every if you create one USDT, there is a corresponding US dollar. That is, if you create one USDT, there is a corresponding one US dollar that is stored in the bank. That is how we ensure that the value of this USDT are being pegged to a dollar. We also have some other cryptocurrency that are pegged to actually like the gold. Like the gold now, let's say I've forgotten the name of that particular token. That is, if you create one of those token, a corresponding gold must be stored somewhere. So that is how those kind of currency are being ensured, that how they achieve their $1 value. The way the USDT achieve it is $1 value. That is, if ten USDT is minted, then $10 is stored in his bank account. And one important usefulness of this USDT is it enables you can use it in your business, because you won't be worried with you won't be worried that okay, the value of this coin will change, so they are stable. Then let's move further into what we have. We've talked about what altcoin is. We have Ripple, Litecoin, Cardano, Solana. So, and one thing we need to know is that Bitcoin just gave us like an eye opening to a kind of technology that will revolutionize our world. So now people realize that okay, Bitcoin enables us to just have a decentralized currency, a currency in which no central authority. So now they now realize that we can also create other stuff. Let's say we can create a contract. In this our world now, a lot of if the normal approach of just signing contract, a lot of things can happen. A contract can be burned, a contract can be manipulated and all that. So now they now realize that okay, blockchain can be used to solve this issue, and that is why the likes of Ethereum was created. For the Ethereum was created. So Ethereum now give us a now Ethereum is now give us a new functionality, and the functionality in which Ethereum give us is that we can deploy code to it. So now in unlike the in the normal web 2, okay, not all of us are technical, but I will try and show and explain in simple term. So now in normal web 2, we need to deploy our code to a remote computer somewhere. So now and those remote computer are what we regards to our server. So now in the web 3 space, so now if Bitcoin, we can just only use Bitcoin um to just create currency. Then they now extend this, they now that is when Ethereum blockchain now come in, so that we'll be able to create a digital agreement on the Ethereum blockchain. So now the digital agreements are like contracts, and these digital agreements are represented in code. So that is one difference between the Ethereum blockchain and the Bitcoin blockchain. The Bitcoin just enables us to just give us that cryptocurrency, but with Ethereum give us things other than just having cryptocurrency. Although Ethereum also give us the cryptocurrency, but it also add another extra functionality, that is ability of being able to create a digital contract on it, and these digital contracts are represented in code. So that is one major difference between these altcoins like Ethereum. That is how they are different from blockchain like Bitcoin. Now let's now look at smart contracts. As I said earlier, Ethereum give us like a new functionality that Bitcoin did not give us. And the name of this digital agreement that are stored on the name of this digital agreement that are stored on the Ethereum blockchain are basically contracts. So smart contracts are basically code that are code to represent a particular transaction, to represent a particular agreement. So that is what smart contracts are. And if this code are stored on the Ethereum blockchain, nobody can change it. So that is one importance of using smart contract to that is one importance of using smart contracts. So now let's look at code are basically series of conditions. If this condition is true, perform this action. If condition is not true, perform this other action. Then we look at application of smart contract. So the smart contract they are like code that is representing a digital agreement on the blockchain. So they enables us to create this digital agreement and all that. So that is one importance of this smart contract. So now, so making international trade transfer more efficiently. Exactly. So like, and if you see cryptocurrency like USDT are created with the help of this smart contract code. So that's one. That's also another important. So now if we create this kind of USDT, businesses all over the world can use this kind of currency to accept payment for their goods and services. So that is the advantage. So now we've come to the end of today's class. Welcome everyone. So now we look at what cryptocurrency is. In summary of what we've done, we look at cryptocurrency is a digital money built with the help of the blockchain. And one uniqueness about this cryptocurrency is that it does not have a central authority. Nobody controls the activities that surround it. So it is immutability. It is free from manipulation. So nobody can just come and take any decision. So now we look at cryptography. Talk about how cryptography ensures that information being transferred between two parties are secured. Then we look at the symmetric cryptography. Cryptography ensures that is another form of cryptography in which when information have been transferred to between two parties, the information are just encrypted with one key. And if the other party want to open the information, they use that same key to open the information. So that is what symmetric cryptography is. And we said encryption is basically the process of converting information to another form. We just basically say the process of masking an information. Then we look at the asymmetric cryptography, that is information have been encrypted with information. So in the asymmetric cryptography have two keys. We have the public and we have the private. So the public key is what enables us to be able to the private key it has a the private key is used to like encrypt this information, while the public key is used to open this information. And also another importance of this asymmetric cryptography is asymmetric cryptography now. The way asymmetric cryptography, the way this private key works now is, let's say now after we've created an information, then this information with the private key and then hash. So now for you for you to now for you to verify that it is this person, it is the person that owns the private key that is sending this information to you, all you just have to do is with the help of the public key. So now when you now input the public key will decode the information and tell you that okay, it is Mr. A that is sending this particular information. So that is one importance, that is the asymmetric cryptography. And I made us to understand that this asymmetric cryptography is used in the blockchain to identify that it is this particular person that owns this particular wallet, that is just not another person that want to perform that particular action. So now let's how is this asymmetric cryptography done on the blockchain? So now if I'm a node on the blockchain, I can just submit a transaction that okay, so and so person, I can say that address Mr. A want to send money to Mr. B, and when the blockchain sees the miner on the blockchain will validate the transaction, and they will do the work of carrying out the, although there are more technicality in the background. So the miner will now do the work of carrying out the addition and the subtraction. So now how do the blockchain prevent ensure that it is not somebody that is just acting, that is not we can say asymmetric cryptography enables us prevent impersonation. So now the way the blockchain, so now once information is being stored, the private key of that person is being hashed, and we've talked about hash now. We said hashing is converting a data to, but we can't really say it's hash. The information is encoded. So now when this information is encoded, then the blockchain have its own way of obtaining the private key of the person that created the transaction from the transaction that was submitted on the blockchain. So I won't go deeper into explaining how we submit transaction and all that. So that is one. We can simply say asymmetric cryptography help us prevent impersonation, and the cryptographic hash, we look at it, we look at what peer-to-peer is. Peer-to-peer is basically activity involving just two people, and if you now look at peer-to-peer electronic cash are basically a money that does not have a central authority, that is nobody is controlling the activity that is surrounding it. So and exactly, the cryptocurrency is an example of that kind of cash, because if you want to send your money, you are not using any bank. All you just have to do, go to your wallet, within the next 5 minutes, the money is gone. The money have been delivered to the person you are sending it to. We look at Bitcoin, we look at altcoins, um smart contracts and all that. So this is what we stop for today. Do we have any question? Any question? Do we have any question? Any question? Do we all understand? So, okay. What you say?
I said no question.
Okay. I was asking you a question the other time. You just refused to talk. I don't know. Is it that you don't understand what I was saying? Oh.
I don't understand.
Eh?
Before I could answer the question, you already continue.
Okay. So can you answer it now? Hello. Can you answer it now? Okay. I think this is where we stop for today. Thank you everyone for coming. Have a Today is Friday. Have a wonderful weekend. Enjoy the rest of your day. Bye bye.